Hello everyone, Jim's Garage here again. First of all, just want to say thanks to everyone that's been reaching out to me asking about how the project is going. Sorry I haven't been posting any videos. I kind of didn't think it caught on and that folks were that interested because there's a lot of other folks out there with information on the Vortec stuff. It seems like it's every day a new video about these heads is showing up, but since enough of you showed interest, I'll go ahead and work on getting this put together and showing you guys what I came up with. So a couple of things that I want to talk about are things that I would have done differently if I were to do this project again. And then we'll get into the results. I actually went to a chassis dyno and before and after the work, so I can show you measurable difference in what I did here, and so you have some sort of idea of what you can expect. And then after I show you the graphs, I got them printed off and I have them here with me. I actually do have a little bit of footage of when I was on the dyno, and I'll show that to you. And my first drive after I got the cam broke in, I was super excited about that. And I'll just kind of tell you how the car feels, what I think, and then I'll give you a little teaser about the future plans for my car here. I know that a lot of this has been centered around the engine stuff, but the reality is for me, this is my project car, and these are the things that I'm doing as I can, and the information that I'm finding, I figure might be interesting for some other folks too. I might be taking a unique, I don't want to say unique, a less traveled plan for my car. And that's partly because of budget, and that's also part of what I'm trying to do with it. But I'll just show you guys what I'm working on, and at the end of the video, I'll show you what my next stage is for the car. So getting right into it, things I would have done different looking back with hindsight. The camshaft that I used, it's essentially the replica of the old 3030 Duntov. It was a very popular cam back in the hot rod days in the 60s and 70s. And it's derived from the cam that was in the 69 Z28 Camaros with the famous DZ302. That was a superb engine. It was a solid lifter, flat tappet, and it got a lot of praise. The Trans Am series cars, they used, I don't know that they used that very specific cam, but they used something similar. And so when I was starting this project, this actually started for me probably 8-9 years ago. And it's just been until recently that I've actually been able to start doing what I was talking about. So when I was looking at a camshaft, or I was talking to folks about like, hey, I want to hop up my car, like, where should I start? What's something easy that I can get my feet wet? And I was sold a camshaft. And then I didn't know anything about camshafts at that time. The closest that I could decipher was the bigger the lift, the better the cam, but that's all I knew. And at this time, I can tell you that that is a very small portion of the camshaft. There's a ton of information out there on how to decipher camshaft specs, so I'm not going to pretend to be an expert and tell you what I think is the right cam, because when I'm choosing a cam, I'm looking to other people that know more than me to figure that out. So the reason I might have gone with a different cam is the one that I chose, it was a great cam, as I said, back in the 60s and 70s. Cam technology and the understanding of how camshafts work has evolved a lot since then. And I don't have a graph to show you, but while my cam was good for the day, for today's standards, it's actually okay. I mean, it's a good hot rod cam, but you could definitely get better. And if you had the budget, and I didn't at the time when I was working on this, a roller lifter conversion would be a huge upgrade. And that opens the door a lot for different cam designs. You can change the ramp profile, and it really gives you a lot of versatility. Whereas with sticking with a traditional tappet or mechanical style, hydraulic or flat, you're kind of limited. And that's where I am right now. I don't have a roller system. It's a flat tappet cam, solid lifter, and it does good. I broke it in, I've been driving it all summer. I don't know, I've probably got maybe a couple thousand miles on it, and I love it, it's great. but I do know that there's better out there. So I don't know that I would necessarily recommend the cam that I have for your build. I would do some research, and honestly, the easiest thing to do would just call competition cams or Howard's, tell them what you're working on and what kind of car you got and what you're planning on doing. And those guys can really steer you in the right direction. Another thing that I wished I had done differently was on these heads, and in previous videos I talked a lot about the modifications I was doing. One of the things I missed was drilling out the push rod holes. And part of the reason I needed to do that was because the bigger cam and higher lift that is. And then second, I switched to 1:6 ratio rockers. So when you do that, the push rod going through the hole in the cylinder head actually contacts the cylinder. So you have to enlarge that to a 1/2 inch. I wished I had known that, because I would have done it while the heads were out of the car. I did it with the heads in the car. I don't recommend it. It was a very time-consuming, painful, worrisome venture, but I got it done. And I'm just going to tell you right now, along with the other stuff that I said in my video, drill out the push rod holes. And I would almost say do it anyway, even if you're not going to run 1/6 rockers, just because you have that assurance of clearance. And you're not going to hurt anything. It's not going to go into the water jackets. Just take a 1/2 inch bit, and that hole where the push rod goes through, drill it out, and do it before you put the heads on. Do it before you assemble them. That way you can clean everything and you don't have to worry about shavings. Another thing that I might have done different, and again, this is sort of a budget. At the time, I was working with the money that I could, and I almost wish that I had saved more and converted to screw-in studs. Right now I'm running the 3/8 pressed-in studs. I haven't had any issues. They don't appear to be pulling out. I think that's partly because the beehive springs, they don't have the tremendous pressures that like a dual coil spring would. So I haven't had any problems, but it would be nice, maybe for assurance in my own mind, if I had a 7/16 screw-in stud. I wouldn't have to worry about them pulling out, and I also wouldn't have to worry about that deflection on the stud of the rocker. And I did, I converted to a full roller rocker, 1/6 ratio, as I said earlier. And they're a little bit heavier than the stamped steel units. And it would just be nice to know that I'm not going to get any movement from that stud. So that's something that I wish I had spent the extra money to do, was go ahead and put in the screw-in studs. There are other things that you could do. Like I'm still running the stock 194, 150 valves, intake and exhaust. I wonder what it would have been like if I had upgraded to 202s and 160s. But again, that's machine work, and that costs money, and I didn't have enough of that at the time. Again, if I were to maybe decide to tear back into this and say do a different cam, maybe a roller cam conversion, and I was going to take off the heads, yeah, I might look at machining out and running the larger valves. I also might do, not necessarily porting, but cleaning up the entire ports inside the cylinder heads. From my last video, you'll recall that I only did the bulwark, and I blended right behind the valves in the intake and exhaust. And while I believe that helped, I kind of wish that I had gone ahead and just cleaned up the entire runners. And I don't mean enlarging them, I just mean all that sort of rough casting in the runners. I wish that I had just cleaned it. And I'm not talking about a polish. I understand that doesn't actually help the flow. You want a little bit of a rough finish because it helps the air tumble. It creates this sort of boundary layer. But there's, in the cast, it's actually this sand type material. And you can see in the runners where those halves come together. And when you look inside the runner, there's this almost seam of cast iron on either side. And I just wonder if I had cleaned up the entire runners, if that might have been even just a little bit more. And I'm kind of nitpicking here, but these are just things for you to consider if you're going to go to this route. And again, a lot of folks have said this, and I'm not going to disagree. If you have the money to go ahead and get them magnafluxed and checked, go ahead and do that. I haven't had any issues. I didn't magnaflux mine. I think I got lucky and I found a pair that wasn't cracked. I have heard that these have a tendency to do that, although I haven't had that problem. There's not a lot beyond that I think I would do, because at that point, when you start spending money on machinery for, say, if you do machine for the valve springs, for instance, say you don't want to go with the beehive, you want to use a traditional dual coil. So you got a machine for that. And then with the cost of the magnafluxing, if you're going to resurface the deck of the heads, those costs start adding up. And then like if you want to go to the bigger 202 valves, that's more machining costs. And in my mind, that's where you start to get negligible for if these are worth it, because you can order from Blueprint a set of aluminum heads that will outflow these most any day of the week, and they're $800. And I would say that's a good budget option head. I've heard, I'm not sure if it was Pro Max, that's what it was. And there's been a handful of other pretty affordable aluminum cylinder heads that are out there. And that's something to really be conscious of. Like if you're gonna start working some Vortec heads and really start investing in them, maybe before you drop the dollar on them, go and look at aluminum cylinder heads, because the aluminum, as we know, it's lighter. I mean, these are freaking, I don't know, they're like 40 or 60 pounds a piece. They're heavy. And with the aluminum, that's weight off the front end. And then also the heat issues and the able to go a higher point in compression without detonation. There's a whole list of reasons why the aluminum can be better than cast iron. But then on top of that, when you have the superior design of the combustion chamber and the runners, and then also the heads might already be machined for screw-in studs, there's a lot of benefit to going to an aftermarket head. And there's that dollar amount, that threshold, in my mind, is around $600, because if you're looking at $600 to put into these heads, then you might as well just wait a little bit longer and pay that $800 for the Blueprint or the Pro Max or whatever it is. And then if you can save even more, you get into the $1,000 range. There's a lot more options that open up for you. So that being said, though, with where I'm at budget-wise, and also I wanted to cut my teeth, I wanted to learn how to do this, I'm very happy with the results. And so that's the next part of the video. So let's talk about the results of what I got from my conversion. So what I'm going to show you here, this is the graph from before I did the engine work. And that engine, it had, I think it was 76cc truck heads, or sorry, 76cc chambered truck heads. I don't know what the runner was and all that sort of stuff, but they were a low performance cylinder head. They were meant to just be in a truck, nothing special. The camshaft, it was an RV cam, and I have no idea what the specs on it were. It ran all right, but obviously I wanted more, and you probably do too, because that's why you're watching the video. So here's the graph. That's what it looks like. This top line here, that's the torque, and this bottom line here was the horsepower. So, and I had 2 runs on this, and it was about 220 horsepower, and that was around 4,000 RPM. And then the torque was at 330, and that was at about 2,600 RPM. So it, as you can see, I mean, the torque started off well, but then it was just downhill from there. And the horsepower, it never even really got a chance to turn into anything. I mean, the engine was all right. It was fun to cruise around in, but honestly, if you tried to run it out in the RPM, it was disappointing. You're just left there like, where's the rest of it? I want more. So obviously that's why I got into doing this change. That's the same reason for most of you. You want more. So after everything, I went back to the dyno, and these are the new results. Now, there's two lines on, or two sets of curves on here, and I'll explain that in a minute. But the max power, horsepower, I got 335 horsepower at 5,700 RPM. And again, both of these, this is a chassis dyno, so this is measured at the wheels. So if it seems low, that's why, because you have to take into account the losses in the differential and also the accessories. Your water pump, your alternator, all that stuff, it takes power. So this is essentially, this is the truest horsepower measurement because it's what's actually getting transferred to the ground. And while yes, engine dyno numbers, they're impressive. They look great because the number's always higher because you don't have the parasitic losses. So take this with, I'm not a grain of salt, but I guess perspective, because this is what you're actually going to feel, because this is what you can actually transfer to the ground. So like I said, 335 horsepower at 5,700 RPM, which that was a big increase. That was 110, 115 horsepower increase. And RPM, it peaked 1,700 RPM higher than it did before. And I'll hold these up next to each other so you can kind of see that perspective. And then our torque, it peaked out at 350 at 4,300 RPM. So, and that was an increase. All right, so that wasn't as great of an increase. So we got an extra 20 foot-pounds of torque, but at a higher RPM. And so the reason there's two lines on this graph here, so the lower set of lines, that was just my initial run. That was, I showed up and we ran it just to get a baseline. And what I did is I actually rented the dyno for an hour so that I could tune it on the dyno chassis. And this is important because I actually found out that I was a little bit off in some of my setup. And the only way you can know that is actually by going to a chassis dyno or even an engine dyno and tuning it to see what the engine wants. So this lower curb, threw it on there, stabbed it, that's what it got. So the upper curve, that was my final after I adjusted timing and did a little bit of jet adjustment in the carburetor. And so just from the tuning, so when I initially showed up and just ran it, 311 horsepower and 328 foot-pounds of torque. So just in the tuning, I went from 311 to 334. That's a 13 horse, or sorry, that's like an 18 horse increase just in tuning. And then on the torque side, we got a 22 additional foot-pounds of torque. And that didn't cost me any money. I mean, yes, renting the dyno costs money, but all I had to do was change the timing and some carburetor jets. So that was almost free horsepower. It was just a matter of figuring out what the engine wanted. And one of the reasons I wanted to show you this is because that is a very important thing for your engine. One of the things I noticed, so after I did this tuning, I smelled a change in the exhaust. And it smelled cleaner, if you will. It had a sweeter smell to it. And before, like, I was pretty confident that when I went in there, I was going to find out that the engine was running rich. And actually what it wasn't necessarily that my jetting was that far off. I only had to change it to 2 jet sizes in the primaries. The timing was off for the burn. So what I was smelling coming out of the exhaust, what I thought was rich, was unburned fuel because my timing was far enough off that burn wasn't happening inside the cylinder. It was getting into the exhaust and then not getting fully burnt because of the turbulence. So And the other thing was, when I drove it home after tuning it, the throttle was much more responsive. It felt smoother, the engine itself, during acceleration, and just all around there was an improvement. And I went home from that dyno not only satisfied with my results, but also after the tuning and thinking like, wow, this just that made a noticeable improvement in the driving characteristics of the vehicle. So I would strongly encourage you that if you're going to do any sort of engine work, even if it's not Vortex or anything like that, get it tuned. If it's on an engine dyno or a chassis dyno, to me, it's well worth the money, because to rent that dyno for an hour was $150. And so if you think about it, for $150, I got an extra 20 foot-pounds of torque and 20 horsepower. So that's fairly cheap, honestly, if we're looking at costs per horsepower. And then also, like, you have that satisfaction and assurance of knowing that your engine is running in its optimal state. So the other thing that I wanted to show you here with this other graph. So this was my final with the power numbers. This lower section down here, this is actually my air-fuel ratio. And so this blip right here that you're seeing, this was just the delay between me signaling the dyno operator that I was going to hit full throttle and me actually hitting full throttle. So that's what that little is. So you can kind of ignore that. But this right here, this is what we want to see. This is around 12.47 for my air-fuel ratio, which is pretty good. This little blip right here, all that is the transition. This is the primaries, and then this is the vacuum secondaries opening right here. That's what that is. But really, even then, that was not a huge change. That's a half a point. So my the spring for my vacuum pod, that I got the right one in there, because there's barely a hump in the primary to secondary transition. And it's a very stable curve. And honestly, this is another reason that I would encourage you to do dyno tuning, because you can get this air-fuel ratio dialed in. And at least with a carburetor, I know that there's EFI units out there that they'll tune themselves for that, and that's great. But if you're like me and you want to run the old controlled fuel leak, this really helped me get that dialed in. And just for illustration purposes, just to show you the stark difference in before and after. So on my left, before any of the engine modifications with an old truck motor and RV cam, and the Vortec heads and bigger cam and intake and carburetor on the right. And one of the things that I want to point out here, so one of the reasons I'm very happy with this camshaft is honestly how this whole, like, if you were to just look at this section right here, everything, there's no sharp drop-offs. Like, even out here at 6,200 RPM, it doesn't just fall off. It gently starts to roll over. And that's a good sign, because that, for one, means that our valve train is still in control. Those springs are doing their job and they're working great. And also, I feel like I did a good job here with the heads and the cam and the intake, because this is fairly flat. I mean, if you want to look at this even for drag racing or road racing, if you're operating in the 4,000 to 6,500 RPM range, or even 3,500 to 6,000, I mean, wherever you are in the power band, you're either going to be in the meat of the torque or you're going to be up in the meat of the horsepower. So this is actually a very broad power band. I mean, you have 2,500 RPM of operating range up in your, where it's going to perform the best. And it's not too bad, honestly, down here for the initial run-in at 2,000 RPM. I mean, we're above 250, like 275 torque. And again, this is at the wheels. So I'm pretty happy with these results. And again, the car drives great. It's a completely different experience now. It is way more fun. And a little bit of perspective on the chassis dyno numbers. So I was talking to the dyno operator when I was there. And again, shout out to the guys at Gap Tuning. They're the ones that helped me out. They're over in Emmett, Idaho. If you guys want to work with them, I'd say they're good folks to work with. They got the equipment, they helped me out, and I really appreciate what they did. But talking to the dyno operator there, I was asking him, so he had a 5th gen LS3 Camaro sitting over in the corner, and I just asked him, I said, just so I kind of know, because that's sort of my benchmark, what does that run on the chassis dyno? And he actually pulled up a graph for me, and I want to say it was maybe a 12 or 13. Anyway, LS3, it had catback exhaust, a tune, and I can't remember if it had a cold air intake or a bigger throttle body, but anyway, some mild bolt-ons in a tune, nothing major. And he pulled up that graph and he actually overlaid it with mine, and at peak, that one only made 18 more horsepower at the wheels than what I am. And I was actually quite surprised by that. I was expecting it to be down maybe 40, 50 horsepower from what that does. So, and he was telling me that before, he didn't have the file on it before the modifications, but he was saying that a stock 5th gen Camaro with the LS3 was almost an overlay with my graph. So that kind of is a gauge, a way of metering where these modifications landed in compared to something modern. So then that leads me to my next part of, so like those are the chassis numbers, and yes, they seem low, but if you do the math, which I did it at a 20% loss, that puts me at about 415 horse and 450 foot-pounds of torque at the crank. Now, granted, this is an estimate with 20% loss because of the drivetrain. And I picked 20% because I've heard some folks say that like 25, 30 for older transmissions. And if I'd still had the old TH350, then yeah, I might be estimating it at a 30% loss because that's an old automatic, but this is a 5-speed manual transmission. And so I didn't want to, because if you calculate with a higher percentage loss, you're actually sort of bumping the number up. I can't remember exactly, but I think if I had calculated it at 25 or 30%, it was more like 450, 460 horsepower. So I kept the calculation estimate low because I didn't want to seem like I was fluffing my numbers. So we're pretty close to what a stock LS3 is, because GM, I think they advertise those at a 420 horse and like maybe 430 torque. So we're in the neighborhood of what an LS3 does. And honestly, I'm super happy about that. My goal when I started this whole project was 400 horse, 400 torque. So to exceed both those numbers, I'm happy. So yeah, and those are the results. I'm very happy with it. And real quick, like the difference in the car, and I took a video of my first sort of rolling into it after I got it running. I broke in the cam and everything. Wow, big difference. I mean, I'm not saying I'm king of the street out there or anything, but what it was before to what it is now, it is so much fun. You feel that sensation of acceleration. It actually puts you back in the seat now, and it will light up the tires on demand. It's excellent. I love it. And plus the way the engine sounds. I mean, the chart here, my peak numbers, like I said, the peak horsepower was 5,700 RPM, but I revved it out to 6,200 on the dyno. And I know that it'll go to 6,500 because I've done it out on the street, and I've taken it about as high as 6,800, but I don't want to push it because I don't know the bottom end in this engine, and I haven't built it, so I don't want to break or spin a bearing. And I did install a MSD 6AL box, and it has the dial-in rev limiter. And I think I've got that clocked in at about 6,500 right now. And that's just to keep everything safe. It's not that the engine won't rev past that. It definitely will. This valve train, it wants to rev. but I'm just trying to be safe with the bottom end. But to kind of give you an idea of the difference, before, revving this thing to 5,000 was almost cringeworthy. It was just like, oh, it sounds bad. Like it's not happy. It just doesn't want to keep going. It just, it does. And we can see in the chart, like it's not wanting to give anything. And now with all that power at the top end, it is way more fun to drive. So for a street car where I might get into some amateur racing events, like it's going to be a lot of fun. And I definitely recommend this to anyone that's just wanting to obviously make some more power and have some fun with it. So that's pretty much it for the results on what happened here. I've been driving it all summer and it's well into winter now. It's been parked, but engine's been running really good. I've done an oil change since the break-in. The oil looked great. I didn't have any problems there. The engine has never gone above about 185. I've got a aftermarket aluminum radiator in here, and I think it's a 180 degree thermostat. And honestly, the car's been great. Take it out for a cruise. You go get into it a little bit, and it does not overheat. Sitting in traffic, it's totally fine. And that's with the factory style clutch fan, not even electric units in there. So everything's been working well. Trying to think of what else. Oh, another piece of advice, do not reuse push rods. I did that and I ruined a set of rockers, and I'm lucky that I didn't ruin the engine. I have some pictures. I'll go ahead and throw that in the video here for you to see, but that was a mistake I made. Learn from my mistakes. When you're doing this, just get new push rods. Just spend the money and do it. You'll save yourself some heartache and some potential even more money lost. Like I said, I ruined a set of rocker arms that way. So what had happened, I actually have the push rods here somewhere. So the ends of the push rods, the ball end that goes into the lifter and then also up into the pocket of the rocker, it just wore out. It mushroomed, and one of them almost completely closed off the oiling hole. And that when it lost that smooth round end, and it opened up a gap, and it just started hammering against the end of the rocker, and it beat the piss out of the push rods. And I think I ruined 8 or 10 of them. And those same 8 or 10 push rods that went bad ruined the rockers as well. Like that cup in the rocker that the push rod sits in is destroyed. It looked like somebody did some really crappy welding in there, and there's just metal boogers all in it. So it was bad. So new push rods. If you're doing engine work like this, just new push rods. I think I am probably going to look into some sort of better oil pan for oil control. I want to get into autocross, and I actually picked one up at a swap meet. I'll show it to you at some point. So right now I just have this stock, the big hump sump at the bottom. And I picked up one that has more baffles, and it's got sort of wings to help with the oil control. That's something I'm going to look into doing sometime in the near future. Another thing probably you guys are curious about, so I've got vacuum operated brakes, and so my big cam 254 duration at 50 and 530. A couple last points here, and then I'll get to wrapping this up. Something I see a lot on the forums and whatnot, they talk about brake operation, vacuum operated brakes with bigger cams and whatnot. So my cam is 254 duration at 50 and 513 lift with a 114 lobe separation angle. And I am running the factory vacuum operated brakes. I actually didn't notice much difference, if any, when I did the whole swap. They still work well. They still, I haven't had any issues. It doesn't seem like it's low on vacuum. And when I was doing the kind of doing some of the initial tuning after I broke in the cam with the idle mixture and whatnot, I'm running about 9 inches of vacuum. I know that's kind of on the low end, but I haven't really noticed any problems with running that. And I did my that tuning. You use vacuum gauge and you adjust your idle mixture screws. I have a Holley 750, so I adjusted the idle mixture screws to get that vacuum at the highest and adjusting the RPM, and that seemed to work pretty well in the AFR readings that we saw in the dyno results. So that is something that I think I was a bit lucky, or maybe the wide lobe separation angle helped. I didn't lose the use of my power brakes, so that was good. Another thing that to add to my previous part about things I would have done differently. So with the porting on the heads, something that I didn't consider until afterwards was port matching the intake manifold in the cylinder heads. I wish that I had gone ahead and done that. I wish I had taken the time to port match the intake with the heads and the gasket in between them. I think that could have been, maybe it might have been small, maybe 5, maybe up to 10 horsepower, I don't know. But that's another thing that if you're going to go ahead and do that bowl work like what I did, maybe go ahead and look into doing the port match on the intake to the cylinder heads as well. And so I'll show you a couple videos. My first run, I was just out on the street doing some testing. The first kind of solid pull after the conversion, and forgive me, I was giggling like a little girl at the end of it because it was just such an improvement. And then I'll show you the dyno video. I'll show you both my initial run. I know I have a video on it of here previously, so maybe I won't post the video of the first dyno run, but I will post a video from the new dyno pull. And so then after that, I'll give you a little preview of what my plan is next for my Camaro here, and we'll go from there. So thanks for watching. Let me know what you guys think. I'll do my best to answer questions in the comments and whatnot, and thank you. Okay, here's the preview of what's upcoming on my 70 Camaro. I've got wheels, tires, and brakes that are going to be the next stage. So these are Riddler brand wheels. They're model 607. I'm going to be doing 18 by 8 in the front and 18 by 9.5 in the rear. I believe the front wheel size is going to be 245 40s in the front, and then 295 40 in the rear. And these brakes are off of a 5th gen Camaro. They come on the SS and SS1LE. They're factory Brembos, 4-piston calipers with 14-inch rotors. And these parts here are the conversion parts necessary to make this brake system work. So this is a complete spindle replacement for my Camaro, all new hub, and the spindle itself has been modified. Let's see if I can show you. So this is where a lot of the modification has happened. There's some cutting and drilling, and then the addition of this bracket, and they make this bracket in-house. This is what the caliper is going to bolt to, and then the cutting and whatnot is the clearancing for the new caliper setup. And then these brackets right here, this is for the rear end. This will fit a GM 10 or 12 bolt. I have an 8.5 inch 10 bolt in the back. And the other cool thing is, so this particular setup, I opted to try and use the parking brake assembly from the 5th gen Camaro, because I've got a complete set of the brakes. I've got the front and rear, there's the rest of the calipers. So I have all 4 rotors and calipers. So I'm going to try and do all 4 corners. And this will allow me to retain the parking brake, which will be nice because currently I don't have one. These are just some of the random bracket parts for the parking brake cable to attach. And then with that kit, I also got conversion stainless steel braided hoses. And this is all of them. I think there's 5 pieces in here for the front and rear. And so all of this kit right here, I got from bigbrakeupgrade.com, and it's a guy named Scott that runs that. He's been really helpful and really patient with all my questions, and I feel like this is a pretty good package. I have found other companies that they do either just the rear bracket, or they sell some sort of bracket like this here, and then you have to do your own cutting and drilling on your spindle. And then different companies, you can get, you can replace the combination disc hub, like what's on the car right now, to this aftermarket hub right here. And these particular ones, these are from a 76 to 80 Camaro. And the reason I went with that is because they actually have a bigger bearing. So talking to Scott, he was saying that they'll handle more stress, which with the bigger wheels and tires and the bigger brakes, there's definitely going to be more stress on that. So I opted to upgrade to that. And as of right now, it looks like everything is going to work. The biggest issue that I've run into is wheels that will actually clear the caliper. These, as they are right now, they actually won't clear the caliper. I'm going to have to get a spacer. But from the research I've done, spacers don't seem as bad as what everyone thinks, especially if you get a hub-centric spacer. So I got to take some measurements and get those ordered up. And this is going to be my next project for this winter. So the wheels and tires, they were sort of necessitated by the brakes, because with this larger diameter rotor and the bigger calipers, you have to run a minimum of an 18-inch wheel. I was originally just wanting to go for 17s, but looking at a lot of pictures and other folks running the 18-inch wheel, I decided it doesn't look bad. It doesn't get too fast and the furious. And I personally really like this spoke pattern. And I'm hoping everything is going to go together pretty well here, but I will video this process as well, and you guys can let me know what you think. But that's what's upcoming. Again, thank you for watching.